Hello children. So once again I'm here with a new video for you all, and it is based on hydrosphere. Okay, and as you all know it very well that we are having different spheres on Earth, right? Out of all the spheres, hydrosphere is one of the important sphere what we have on Earth. What are the four spheres we have on Earth? Number one is lithosphere, that is the land area. Okay, number two is atmosphere, the entire the air mass, okay, surrounding the Earth. Number three is hydrosphere, that is water which is actually present on Earth. And number four, the most important one, is actually the biosphere. Biosphere, or you can say simply the sphere which has got life within it, that is biosphere. Okay, so a part of hydrosphere, a part of atmosphere, and a part of lithosphere comes under biosphere. Wherever the living beings are present, that comes under biosphere. So now here we have to talk about hydrosphere. And before I proceed with this video, I want to remind you once again, do subscribe the channel and also share the link of this video with your friends. Okay, so let's continue with it. First of all, hydrosphere. What is actually which part of water is actually included in hydrosphere? This is actually whatever form of water is present on the Earth's surface, that is considered as hydrosphere. And within that only we find different water bodies there on the Earth's surface. The underground water, the water which is present in the form of the snow-covered peaks and in the form of snow, or the ice, right, in the form of glaciers, or even in the form of water vapor, the gaseous state also. So in all the three forms, whether it is solid, it is liquid, or it is gaseous state, all the three states are forming a part of hydrosphere, right? Now here in this topic, just we have to discuss a small part of the vast topic hydrosphere, just a small part of it. And what is it? Basically we have to discuss here about the ocean water movements. What are the different movements we can find in the case of ocean water? Now, if we talk about these main movements, the most important type of movements, what we find here, the first one is actually the ocean waves. Number one is ocean waves, number two is the tides, and number three is the ocean currents. So what are these ocean waves? First of all, you must have seen, it's a very normal thing over the oceans, or generally the water bodies also. Especially the stagnant water, wherever it's there, we can find waves very clearly there, right? Now, what is it actually? It is a rhythmic or oscillatory movement, okay? Oscillatory movement of ocean water that carries energy through matter or space, right? That is called actually the wave, okay? Now, when we talk about waves, waves are basically having different parts, and as they travel, you'll find always, you must have noticed, na, upper part of it and the lower part, again upper part and lower part. So the upper part of it is called the crest. You can see here, this part, the A is called the crest, C-R-E-S-T, and the lower part is called the trough, T-R-O-U-G-H. And again the next crest, then again the trough. So in between the two crests, the length in between, or you can say the distance in between the two crests, is called actually the wavelength. Okay, that is called the wavelength. Now, what can be the reason behind it? The reason behind the movement of waves is, the most important thing is the winds. The movement of winds cause the creation of waves in the ocean water. Now, one thing you should remember here, we are not talking of some other type of waves like tsunamis and all, okay? That is not a normal wave which we find always. That is something different. Here we are talking about the normal waves which we can see every time these are present on the ocean water or the sea water. We are talking of that wave. Okay. So whenever the winds blow with a high speed, you will find higher waves are caused. If the winds are blowing very gently, like a breeze is blowing, so you will find the same way the waves caused are very low waves are caused in that. Okay, so that is called, actually the height of the wave is whenever you will find the high speed winds blow, that causes the higher waves to be caused, and that is actually this you can see here. Okay, the vertical distance it covers, that is called the wave height. Okay, now let's talk about the causes. Basically, under the causes, we know that the wind is mainly the factor behind the causing of waves. But velocity of wind, just now I was telling you, the velocity of wind, that is one very, very important factor. Number two is that the duration of wind. That means for what duration the wind is blowing and in which direction it's blowing, right? If it will blow in different directions, that will not cause clear waves to develop. Okay. And the next thing is the distance of over which the wind can blow unhindered. That means constantly in one direction, for what distance it can cover, right, without any obstacle. So that is actually, all these factors are responsible for causing waves. Now the next type of the ocean movement we have to discuss here is the ocean currents. What are basically the ocean currents? Ocean currents are simply, you just understand in this way, like a narrow stream of water in the ocean body. When it flows from one part to the other, that is called ocean current. Now, as the name suggests, ocean currents means these currents, these movement of water is only seen in the ocean bodies. Okay, these are not seen any river, these are not seen any pond or any other water body, and that's why it has got the name ocean currents, right? You can see here all these ocean currents in the world map. You can see the different areas are it has been shown: Agulhas current, then North Equatorial current, South Equatorial current, right? Then West Australian current, East Australian current, Kuroshio current, Oyashio current, right? Then Californian current, in the same manner Peru current, then this side it's Brazilian current, then Venezuelan current, then you can see here the Oyashio and Kuroshio currents, right? The Gulf Stream and the Labrador current, Canary current, North Atlantic drift. All these are the different currents which we can find in different parts of the ocean bodies all over the earth, right? And these are called by the same name where they actually flow very close to that landmass. So according to that region only, these are given the names. Now let's see the types of ocean currents. There are basically four types of ocean currents. One is actually on the basis of the temperature of the ocean, of the water. We can say that these can be of two types. One is warm ocean current, the other is cold ocean current. What is now warm ocean current? As the name suggests, these ocean currents are having comparatively a little, the temperature is a little higher, right, as compared to cold ocean currents. Cold ocean currents are having water which is having low temperature. Now what can be the reason behind that? Warm ocean currents generally are seen, they originate in the equatorial or the tropical regions where the surrounding temperature condition is quite high. Okay, so naturally the water temperature will also get a little higher. But as compared to the colder regions or the polar regions, you can say, from polar regions, if any ocean current is coming towards the equatorial region, what will happen? What type of current is that? Because that water is coming from polar region, naturally it is having the water which has got low temperature. So that is called cold ocean current. Same way, the surface water current and deep water current. Surface current is that which actually is seen on the surface of ocean or till certain depth only, right? And this surface ocean current, actually it constitutes of about 10% of all the total ocean currents what we can find all over. So you can take it like from the surface till almost 400 meters or 450 meters depth. That is the limit where these surface water currents move. So this is one type. Next type is the deep water current. According to the depth only, we can say that second type is deep water current. Now what is it? As the name suggests again, this ocean current generally moves at a greater depth, and it covers almost 90% of the total ocean currents which are seen. They belong to this type, and these are seen at greater depth, below 400 meters or 450 meters, and till the base, or the, you can say, the ocean basin. Within that depth, if the ocean current is flowing, that will be taken as the deep water current. That is the only difference. Okay, so basically these four types are there. Now in the next part of it, we have to discuss about the causes of ocean currents. What are the basic causes which make the water to move from one part to the other, right? For that you should know one basic thing, that is actually all these ocean currents are connected with each other, right? All these ocean currents are interconnected. Now, whenever you'll find one part of the ocean current, one part of the ocean has got salinity level is suppose higher in that ocean, and as compared to that any other ocean or the sea is there where the salinity level is low. So what happens then? The variation in salinity level or the density is actually varying in this case. So what happens then? High density water, or you can say the water which has got high salinity level, okay, that starts moving towards the low salinity level, right? The water which has got low salinity or low density, and this continues till the time actually it continues to get an equilibrium, and in actual it never is reached, right? We never find that it stops and the equilibrium has reached. It can never be possible. So this continues like that, okay, and this is one of the basic reasons behind the origin of ocean currents. Number two is that temperature. Just like salinity, you'll find temperature also varies in different parts. As we discussed in the earlier part, warm ocean current and cold ocean currents, these are actually the currents which originate in different temperature zones. So if the equatorial region is there, so naturally any ocean current which is actually moving from equatorial region, that will have comparatively high temperature. As compared to that, any ocean which is there in the polar region, naturally it will have low temperature. So variation in temperature also is one big factor in causing the movement of ocean currents. So number one was level of salinity. Number two is temperature variation. Number three now. Number three is the Earth's rotation. To a great extent, you will find the Earth's rotation also affects the movement of ocean currents. Now in what way? One thing is there, the Earth's rotation causes the Coriolis effect. Okay. Now this Coriolis effect is seen in the northern hemisphere. Always the ocean currents or the winds which blow in that the northern hemisphere, or the ocean currents which move, they always take a right direction. They get deflected towards their right. Okay, or the other way we can say that they start moving in clockwise direction in northern hemisphere. But when you find the same thing, say the similar movement is there in the southern hemisphere, you will find its direction changes, right? Any ocean current or any such wind which is blowing in such an area in the southern hemisphere, you'll find whatever is their direction, they get deflected a little towards their left. Or the other way we can say that they start moving in anti-clockwise direction. It is totally because of the Earth's rotation, or the other way we can say Earth's rotation, which causes the Coriolis force, and this Coriolis force causes this type of movement, right? So this is the third factor or the third cause behind ocean currents. Next is planetary winds. When we talk about the planetary winds or the permanent winds, these are also a determining factor in regarding the direction of the ocean current. One example I'm giving you, like Gulf Stream is flowing along the coast of North America, okay, the eastern coast of North America. As it flows, it again turns down, that is, the clockwise direction starts, right? The clockwise movement starts. And then it actually is taken away. A part of this ocean current is taken away along the northwestern coast of Europe. And what is it now? That is a part of ocean current, so it is called by the name drift. And this is actually happening in the North Atlantic region, so it is called as North Atlantic drift. One big reason behind its formation is the planetary wind, that is westerly. Westerly winds blow in this area. Okay. Another reason can be like the Newfoundland and the Greenland actually, which is there, an island which is present in between. That landmass causes the movement of this drift towards the northeast direction. So this is one of the reasons behind it. Then monsoon winds, to some extent the monsoon winds also cause the movement of ocean currents in different parts, especially in the Southeast Asian countries. And next is the land. Land, just now I discussed that the shape of land affects a lot. That becomes very important to which direction the ocean current will move. Sometimes any ocean current is coming, right, in one direction. One pointed part of the landmass is there. It causes that ocean current to get bifurcated into two parts. So this is the actually the effect of land, okay, landmass which is there. Now you can see here very clearly, this is actually a map showing the currents of the South Pacific Ocean. You can see here. Along the equator, this is actually the equator passing through this part. So along the equator, you'll find the movement of the ocean currents can be seen by red color. This is actually the warm ocean current. And the ocean currents which are coming from polar region towards the equatorial region, these are actually the cold ocean current, right? And you can see this is South Pacific Ocean. So its movement is in which direction? Can you see this? This is moving in anti-clockwise direction, right? So on one side, the cold ocean current is flowing close to the Peruvian coast. The other side, it's coming down, okay, along the eastern coast of Australia. So it's called East Australian current, right? So this is how it moves in the southern hemisphere. Same way, you can see another map here regarding the currents of Atlantic Ocean. Just now I was telling you about the Gulf Stream in the earlier part. This is the Gulf Stream, right? Gulf Stream continues to move like this because we are talking about the northern hemisphere. So these currents start moving in clockwise direction, right? This is the way they move. So Gulf Stream, when it moves further, you'll find this is called North Atlantic Drift as it crosses this part and reaches towards this side. That is the northwestern coast of Europe. Okay, so this is one part of it. Then as it comes down, this is called Canaries current. Then again, it actually takes a round and this way it keeps moving. Clear? This is Gulf Stream is a warm ocean current. While from the northern side, you can see here from the North Pole side, a cold current is coming down. Its name is Labrador current. Okay, and here where these two currents meet, they actually cause very rich area to develop with the planktons. Okay, this is called plankton, and this plankton is the favorite food for fishes, and that's why this area has developed into one of the richest fishing bank of the world, right? So this is one example of it. Then come to the next one, currents of the Indian Ocean. In a few cases you can see here in the Indian Ocean also, in the south of it, you'll find Agulhas current, then Mozambique current and West Australian current. Okay, these currents are moving. Now, the next thing here we need to discuss that is very, very important, that what is the effect of ocean current on the different things. That is, what effect we can see on the climate of the nearby area, or you can say the nearby coastal area, right? The effect it causes in different ways, right? Number one is in the form of precipitation. Wherever you'll find along the coastal part, right, along any landmass, if any warm ocean current is flowing, it causes more and more evaporation. And as evaporation rate increases, that creates more chances of precipitation in that area. Understood? So, whenever warm ocean current moves, that causes chances of precipitation to rise, to increase. But on the other hand, if you talk about the cold ocean current when flows close to any landmass, it reduces the chances of precipitation because the evaporation rate goes down and no water vapor will be there, so there will not be any precipitation at all. So this is one of the effects on the climate of the region. Number two is that in the form of fog, we can see the effect. Wherever these two ocean currents meet, it causes very dense fog to develop. Okay, so this is again something related with the weather condition, or you can say the climatic condition of that region. Number three is that when we talk about any of these ocean currents, right? So these ocean currents always increase the temperature of the entire coastal region. When warm ocean current moves close to that area, land area, it will increase the temperature of that land area. Same way, if any cold ocean current is flowing, that will cause the decrease in temperature. And one of the best effects of this type of movement can be seen along the northwestern coast of Europe, where the North Atlantic drift is actually flowing along the northwestern coast of Europe. And due to this warm ocean current, it keeps the entire coastal area, which should be covered with ice, right, being very close to the North Pole, but it is not. The only reason is the North Atlantic drift, which flows through that region. Because of the ocean current is its nature is warm water ocean current, right? So the effect we can find in the entire coastal area, and thus it helps in, yes, the ships can easily come and go. That means the ports still work, and that is why the trade is actually growing very fast in that region. In spite of being very close to the North Pole, the ports are always open for the ships. This is the main reason for it. Another effect we can find in the case of effects of ocean currents on the marine organisms. Now, how we can study about that? Basically, children, whenever the ocean currents meet, a warm ocean current and a cold ocean current meet, that area develops into a very ideal condition is created there, right, in the water body for the development of planktons. And this plankton, basically, it's a favorite food for a maximum fishes. And this is the reason, because planktons grow up fast in that part. So that gets actually an area, it develops into a bank, right, fishing bank. And it develops into an area where the fishes from all over the entire ocean bodies, they get attracted towards it. And thus another part of trade develops in that region, that is the fishery. Okay, and regarding marine organism, you can mention in this manner. This is how it affects the marine organism. And one more thing regarding the trade you can mention here. As the ships move towards the northern side, that is the northwestern coast of Europe, they find in their way dense fog condition. So that again creates, actually that is some negative factor, because that fog actually causes the visibility to become zero, right? For some time it just becomes zero. Nothing is visible. So that is very risky condition in the case of ships when they are close to the North Pole, and especially that area where the icebergs can be seen a lot. So that becomes very risky for the ships to move in such an area. So that is one negative factor. One more thing here you can mention, that when the ships move, okay, and if the ocean current is moving in the same direction, so there in that case it will help further to the ship to move at a faster speed. So it will save time, it will save fuel, right? And it will be, you can say the movement will be more faster. But the same thing if it happens the opposite way. If the ship has to move in one direction and the ocean current is moving in the opposite direction. So what will happen? The effect will be seen in just opposite manner. That means it will reduce the speed of the ship on one side. Number two, it's you can say because the more time will be required, right? It will take more time in reaching to its destination. Number three is that it will actually cause more consumption of naturally the fuel also. Okay, so these are a few things related to the commerce. These are the effects of ocean currents. Now, one more type of movement is very commonly seen in the ocean water, that is called tide. Okay, tides. Basically, tides are caused due to the gravitation force of moon and the sun also, right? But basically, moon's gravitation force works over it. Regular tides are caused because of that. And how does it happen? Just for once, try to understand with the help of this picture which is there in front of you. Suppose moon on one side, okay, it's okay, fine, its gravitation force is much less than the earth, but still it has some gravitation force, okay. So what happens then? When moon is actually moving around the earth, okay, due to its revolution, it's moving around the earth. When it moves to certain period of time, you will find when it is crossing any landmass, not much effect can be seen. But as it crosses that part of the earth where it is fully covered with water, vast ocean body is there you will find easily the effect of gravitation force of moon. And what happens then? It causes a high tide to be caused, right? That means because of the gravitation force of moon, that part of ocean current which is facing the moon, because water is liquid, so it gets attracted towards the moon, and a higher part of you can say the water gets attracted towards the moon, so the high tide is caused. The level of water rises in the coastal part of that ocean, and as the moon moves to the other side, you'll find the low tide is caused. You can see here very clearly again, there are actually two such conditions on two certain days you will find when this type of thing happens, that is called the spring tide. And which are 2 days? Number one is the new moon day and the other one is called full moon day. Okay, that means on both the 2 days you'll find the 3 heavenly bodies are in one line. Okay, so because they are in one line, so what is the effect? Earlier in normal case, in the earlier part only I was telling you that moon causes the attraction of water, right? Ocean water towards it. That causes the high tides to occur, right? That causes the high tides. Whichever part the moon moves, that ocean experiences the high tide. That is a normal phenomena. It's an everyday phenomena. But when during particular days, that is new moon day and full moon day, what happens here? On these 2 days, you will find all the 3 heavenly bodies. That is, on one side you can see earth, moon and sun. All the 3 are in one line. Okay, and that causes actually together the gravitation force of moon and sun. They work over the water body on the earth, or the ocean water on the earth. And thus the tide which is caused is too high than the normal tide. And this only is called as the spring tide. This is called the spring tide. On 2 days it happens. One is new moon day, the other is full moon day. Clear? And when does it happen? In one complete month, you'll find on the first day and the 15th day. Again the first day and the 15th day. Right? In Hindi it is called Amavasya and Purnima. So these 2 days always you'll find the spring tide is caused. But what about the other type which is given here, neap tide? This is actually something which is again seen on 2 particular days of a month. And what are these 2 days? The you can say the mid of one fortnight, from the first day to the 15th day. In between that, the center, that means you can say the mid point of it, or the day which is lying in midst of the two, right? That means in between the first day and the 15th date of a month, there comes 7th and 8th day, right? That is almost the mid of it. And on that particular day, moon is actually having this position. And this is a position when you will find a quadrature is formed. Quadrature means 90-degree angle is formed. One side it is moon and one side it is sun. Okay. And what is the effect of it now? Because the two heavenly bodies work from different directions, so the tides are actually the effect of moon's gravitation force and the sun's gravitation force becomes actually very less then, because they are not able to cause any tide to be clearly, actually the high tide to be clearly caused as a result of it. So whatever tides used to be there, the normal tides, even it gets lower than that normal high tide. Almost 20% lower than the normal high tide is caused during the neap tide. Why? The reason is the gravitation force get divided. That means the one side the moon's gravitation force is working, and exactly at 90-degree the sun's gravitation force works. So this causes the tides to be to remain at a low height only, and this is called the neap tide. On which day it occurs? In one fortnight, the mid of it, that is the 7th or 8th day, from 1st to 15th of one month, and from 15th to 30th you'll find on either 20th, 22nd or 23rd of that fortnight. Okay, the neap tide occurs. So what is the position of the three heavenly bodies in the case of neap tide? They are forming a quadrature, means a right angle. So these are the two tides, spring tides and neap tides, right? You can see the tidal current, how it moves. Actually, when the tides come, that is called the flood current, and as it goes back to the, you can say it goes away from the coastal part, that is called the ebb current. Now, what can be the advantages of tides? How these are helpful in various activities? Keeping this in mind, if you just think of just a few things you should remember. One thing is that these tides actually, they help in making some of the rivers navigable, okay, for ocean going vessels. Especially a few ships are able to enter such rivers with the help of tides only, right? You can take the example of London, Kolkata. They have become important ports owing to the tidal nature of the mouth of river Thames and river Hooghly. Because the tides, when the tides come, it causes the level of water to rise, and that makes the ships to enter in the river water, and thus they can reach these ports. So the level of water rises, that makes these ships to reach to their destination easily. And as the, again after that the low tide comes, so they remain there only. Again the next high tide comes, they get a proper water level, they again move to the deep sea area. Okay, so that is actually one of the, you can say, advantages what we are getting with the help of these tides. It helps in the trade, right? Next is fishermen. The fishermen actually go to the open sea, right, for fishing along with the high tide. Once the high tide comes, they are able to go to the deep sea area, or you can say the open sea area. Okay, and as the low tide comes, they come back along with it. Okay, so again it helps in the fishing. Okay, for the fishermen it is very helpful. Then next is the tides. Actually, this is again one very important point. The tides help in clearing. You can see here, this is a river, right? It is joining the ocean. This is the mouth of the river, and as the tide comes, it causes actually washing away, right? It washes away the refuse or the waste which is actually released by the coastal towns and the cities. So it actually causes this waste or the refuse to be taken away from the coast, right? So it clears that area. So that is again one of the advantages of the tides. One more advantage you can just note down here, that it brings many shells and other sea products on the shore. Many times several minerals we can get on the shore. Then another thing is that the tides keep the sea water in motion. The entire sea water keeps actually it continues in motion, and this keeps the water to remain clear. Just now we discussed in the earlier point, the water remains clear, and moreover it avoids the freezing of water. When anywhere we are getting like the water is there close to the frigid zone or near the poles, there are always chances of water to get freeze, right? But the tides are the reason which keep the water in its normal condition. Okay, and many ports in England also, one example you can take, do not freeze at all in winters just due to the tides. Regular tides are caused in that part. Then another use of it these days we can find, that is actually when we are searching for several non-conventional sources of energy because of a lot of use of the fossil fuels and the effects of that. Okay, and the global warming and the pollution which it causes, we are searching for some non-conventional sources of energy, and in that this is one of the sources of energy, that is the tidal energy or the tidal force, which is actually used to generate the electricity, and a few countries are using it for the maximum potential of it is being actually taken up there, right, to generate the electricity. In the countries like France, Japan have actually several power stations, right? These are installed in the ocean water only, and these power stations, what is their work? They actually convert the tidal energy, right? Continuously they keep on working. The tidal energy is converted into electricity, and this electricity is supplied to the various cities and the other, you can say, the settlement areas or the industries or wherever it is required. Okay, so these are in total the advantages of the tides. So this is all with this topic, children, and what I know, that entire part of it, whatever we have discussed just now, all the points are very, very clear to you now. Yes, so don't forget to subscribe the channel, and also share the link of this video with your friends and classmates, and take the best use of it, best benefit of it. So it's time to say bye now, and till the time we meet again in the next video. Till then, bye.